Hello everyone, welcome to Shibi's chemistry classes. Today's topic is covalent bond. Covalent, or we call them molecular bond. So in the previous lecture we have seen what are electrovalent bond, and we have seen that electrovalent bond is formed between a metal and a non-metal. Electrovalent. Yeah, we have seen that electrovalent bond is formed between a metal and a non-metal, in which metal donates electron and non-metal accept that electron, and while doing so they develop a strong electrostatic force of attraction, and that force of attraction we call electrovalent bond. And they develop positive and negative charge species, cation and anion formation take place, and since we know that opposite charge attract each other, so by that attraction, electrostatic force of attraction develops, resulting in the formation of electrovalent bond and electrovalent compound. This we have already discussed. But what if a compound is formed between a non-metal and a non-metal? Because we are known to, so many compounds are known to us that are formed between a non-metal and a non-metal, by the combination of this thing. So what will happen here? We know that non-metal don't have the tendency to lose electron. They accept. तो सभी accept करेंगे तो फिर bond formation how it will take place, no? That we have to see. For example, hydrogen. We know that it has one electron in the outermost shell, but it will not lose this electron. So instead of losing, it will share, like in the formation of hydrogen molecule. Instead of losing electron, what it will do, because they have to attain stability, and a chemical combination take place only to attain stability. All the atoms, they go for chemical combination, and because they don't have their octet complete or duplet complete, so in doing so they do some rearrangement of electron, and that rearrangement of electron, in this case in covalent bonding, it is the sharing of electron, like they both come close and they share each of the electron amongst one another. So now this electron will belong to this hydrogen atom, and this electron will belong to this hydrogen atom. So how we will define covalent bond now? How we will define covalent bond? The bond that is formed between two atoms by the sharing of one or more pair of electrons. The bond formed by the sharing of one or more pair of electron. So here I have written one or more pair of electron. What does it mean? Means either the sharing of one pair of electron take place, so that type of bond is called single covalent bond. Single covalent bond. Like for example, we'll take hydrogen, chlorine, HCl, and these are the example of single covalent bond. Like HCl, hydrogen we know its atomic number is 1, chlorine is 17, configuration is 287. Now to attain the noble gas configuration, this hydrogen wants 1 electron, and this chlorine also wants 1 electron. So what will it will do? It will share electron. After sharing, now hydrogen is satisfied with 2 electron and chlorine is satisfied with 8 electron. So but here a single pair of electron is shared, so that is why it is called single covalent bond. Fine. Now if two pair of electron sharing take place, then it is called double covalent bond. Double covalent bond. We'll take the example of oxygen molecule. Oxygen atomic number is 8, configuration is 2 and 6. Oxygen molecule O2, that means 2 oxygen atoms are there. Outer electronic configuration, the structure that we draw over here, that is called Lewis dot structure, because we are only showing the valence shell electron. 6 electron, 2, 3, 4, 5, 6. Sharing take place, they form. Now if you count, you will get 1, 2, 3, 4, 5, 6, 7 and 8. So this electron pair belongs to this oxygen atom as well as this oxygen atom. Now both have the configuration 2, 8 and 2, 8, and they form a stable molecule, that is oxygen molecule. But in doing so, they shared two pair of electron, and two pair of electron sharing is taking place. So that is why we call it as a double covalent bond, and we used to represent it with the help of 2 dash. Single covalent bond is represented by 1 dash. Third is triple covalent bond. Third is triple covalent bond. From the name itself, we get an idea that here the sharing of 3 electron pair is taking place. We will take the example of nitrogen molecule. Nitrogen atomic number is 7, configuration is 2, 5. Here we can see that its valence shell contains 5 electron. That means it is short of 3 electron to complete its octet. So 2 nitrogen atoms are there. 1, 2, 3, 1, 2. Outer configuration of 5. Pairing take place. Now this paired electron belongs to both the nitrogen atoms. So now both are satisfied with octet arrangement 2, 8 and 2, 8. So this is triple covalent bond. It is shown with the help of 3 dash. See, dash means whenever we are showing, it is only a way of showing the bond. This dash has 2 electron in it, but in reality in a particular compound there is no dash over there. It is a compound, but we have to show it anyhow, we have to represent it. So this dash shows that a bond is formed. This is a bond. All right, so this is about single covalent bond, double covalent bond and triple covalent bond. And the number of electron that is pairing, that is called the covalency of that particular atom. Covalency. And in hydrogen we have seen that this one electron is pairing with other, so the hydrogen has the covalency of 1. In chlorine also we have seen 1. In oxygen what we have seen, that 2 electron is pairing, so covalency is 2. Nitrogen 3 electron is pairing here, so its covalency is 3. So it is the number of electron that is participating in pairing with the other electron. All right, now next we have to see polar and non-polar covalent compounds. I hope this much is clear to everyone, and if you are watching this video, I request you all to please sit with a notebook and pen, so that whatever I am writing here on the board, just try to write it with me. And in doing so, the things will become more clear in your mind. If you just listen, so it will vanish. When you switch off the video, everything will just disappear from your mind. Isn't it? So the correct way of learning or studying is always sit with a notebook and pen and try to note down whatever. So things will become clear. So next topic is polar and non-polar covalent compounds. So first we will see non-polar. Non-polar covalent compounds. Now what are they? Non-polar compounds. When shared pair of electron, when shared pair of electron are equally distributed, between combining atoms. See, covalent in covalent bond we are only talking about sharing of electron. So what are non-polar covalent compounds? From the name itself, you can get an idea that non-pole means there is no pole, there is no charge separation, there is no positive or negative charge over there. And this will get an idea from the name itself. Non-polar means there is no development of pole or there is no charge separation. When it will take place? And it will take place when both the combining atom are having same electronegativity, almost similar electronegativities. Electronegativity, we know that it is the tendency to attract the shared pair of electron in a molecule. And if I say tendency to attract shared pair of electron in a molecule, molecule means suppose we are talking about this hydrogen molecule. And its structure is like this. See, both are same atoms. That means both are having same electronegativity. There is no electronegativity difference. So who will attract the shared pair? Shared pair means this electron, both the electron. Neither this hydrogen nor this hydrogen. No one will attract the shared pair of electron. So there is no question of developing charge over there or charge separation. Alright. So when the shared pair of electron are equally distributed, means it is equal for both. So both are having same electronegativity, so no one will pull that electron pair. So this type of sharing, wherever it take place, that compounds are called non-polar compounds. ठीक है, like for example Cl2, both are having same electronegativity, no charge separation take place, compound is non-polar. ठीक है, sometimes if the compound is formed between dissimilar atoms, they are also non-polar due to their structure. है ना, there's it is not like if the compound is same then only it is non-polar. No, some compounds they are formed of dissimilar atom, then too they are non-polar, like for example methane and carbon tetrachloride. And they have slight difference in there. These atoms have slight difference in the electronegativity values, but then too they are non-polar. Why? Because of their structure. Structure we'll see of first we'll see of methane. Carbon atomic number is 6, configuration is 2 4. Hydrogen we all know it is 1. Now carbon is short of 4 electron, है ना? So it will not give 4 electron or not take 4 electron. It will share the 4 electron with this 4 hydrogen over here. So we'll make the outer electrons of carbon and hydrogen, 4 hydrogen, make like this. 1 bond, 2 bond, 3 bond, 4 bond. Okay, 4 bonds are formed like this, 4 covalent bond. And after sharing, this carbon has 8 and this hydrogen, each of the hydrogen has 2 electron in its valence shell. Now both are satisfied and form a stable compound. But being formed of these two different elements, they are non-polar. And because they have a very slight electronegativity difference, and their structure is somewhat like the shared pair of electron is at equal distance from all the combining atom, equally distributed है ना? No one is attracting the shared pair of electrons. Similar is the case with carbon tetrachloride. Carbon again 4 electron in its valence shell. Chlorine is short of 1 electron to complete its octet. This is also an example of non-polar. Now we'll see what are polar compounds. Polar compounds, from the name itself we get an idea that they are having pole. means the combining atom should have some electronegativity difference so that the shared pair of electron is attracted more by one particular atom rather than the other, like HCl, like water, like HF. HF is hydrogen fluoride, है ना? We'll see the structure. Hydrogen 1 electron, chlorine 7. Bond formation take place, but chlorine is more electronegative than hydrogen, so it will attract the shared pair of electron is shifted towards chlorine a little bit. So what will happen? This chlorine will develop a slight negative charge and this hydrogen will develop a slight positive charge. Due to the electronegativity difference and chlorine being more electronegative than hydrogen, it will attract the shared pair of electron towards itself. So in doing so, what will happen? Because electron is shifted towards chlorine, so that means it is having a slight, it is not complete cation and anion formation is not taking place. Only a slight negative charge is developed because it has only attracted, it has not accepted. है ना? It is not accepting the electron pair. It is only attracting. A slight negative charge is developed over here and a slight positive charge is developed. That means you can see that charge separation is taking place. Now two poles are formed, isn't it? Two poles are getting formed, so that is why they are called polar compounds. Here H2O, will see oxygen atomic number is 8, configuration is 2,6. So 6 electrons are present in the valence shell. And hydrogen, okay, the sharing will take place like this. या इसको ऐसे बना लें. But oxygen being more electronegative, shifting of electron pair take place and this will develop a negative charge and this will develop a positive charge. So again it is a polar compound. Hydrogen fluoride also same like HCl. Fluorine is the most electronegative element in the periodic table. Fluorine atomic number 9, hydrogen, fluorine, del negative, del positive. So these are polar compounds. This much is clear to everyone. So if more the electronegativity difference between the combining atom, more is the polar nature of the compound. Anything left? So I hope this much is clear to everyone. In the next video, we will see structure of certain covalent compounds. Till then, bye bye.